아까 말씀드린 대로 오늘은 약간 글로벌 행사가 됐기 때문에 오늘 그 TIP와 그 TAC에 대해서 소개를 해주실 분이 페이스북에 이제 싱가포르 APEC 담당을 하고 계시는 브라이언 텐이십니다. 프로덕트 인프라스트럭처 파트너십 팀 리드를 하고 계시고요. 앞으로 모셔서 말씀을 들어보도록 하겠습니다. 여러분 큰 박수로 환영해 주시기 바랍니다. Thank you for being here.
Thank you. I'm Bryan. I work in the Facebook connectivity ecosystem team. What I'll do today is to first share with you why is Facebook even interested in connectivity. We're known as a social media company, so why are we getting involved in connectivity? Last year when Mark Zuckerberg launched our 10-year roadmap, this is what he put up. So in the near term, we will focus on developing the ecosystem. That means Facebook as an ecosystem, Instagram as an ecosystem. But in the long term, we are developing really interesting technologies in three main areas. It's AR, VR, virtual reality, augmented reality, artificial intelligence, AI, and also connectivity. So what I'll do today is to share a little bit about the advances that we are making in AI as well as VR, AR, and then tie that back to why connectivity plays such an important role for us to be able to deliver these content to our end users. And then we talk a little bit about what we're doing together with SK in terms of the TEAC. All right, so first, AI, artificial intelligence. This is artificial intelligence in 1993. This is Jan LeCun, he's our director for artificial intelligence. And in 1993, let's see whether this works. Oops. Sorry about that. In 1993, he's actually, does it work? Could you help me? Yes, so in 1993, he's actually teaching the computer how to read a telephone number. So this is computer vision in 1993. We are not doing that today. What we're doing today is that over the last 5 years or so, there has been a significant improvement in computational power and also AI capability. So if you look in 2012, this is AlexNet, and we can, from looking at this picture, pick out a person. That was all we could do. In 2015, we could pick out a person, we can pick out objects like refrigerators and bowls. We can also pick out animals like dogs. But you can see that it's still not quite perfect because the refrigerator we all kind of know is a rectangular object and not a weird looking object. So it's not perfect. But just last month in 2017, we released a new AI technique called Mask RCNN. And with this, we're able to pick out persons, we're able to pick out the animal, we're able to pick out a bowl in the refrigerator with that level of accuracy, but also pick out finer objects like the cup and the glass you see in the background. But more important, we can now pick out the posture of a person. So this is a 17-point posture of a person, and once we can pick out posture of a person, we can look at what the person is going to do next. We can predict what the person will do next. Is she bending down? Is she going to jump? And you can look at things like masking out objects in videos that is not required. But do we really need huge computing power to do AI? We don't believe that AI should just be in the data center. So what we're focused on is actually trying to get AI down into your phone. And you can see the progression here. In August 2015, to do style transfer. Anybody here know what style transfer is? So style transfer is you take a photograph and you transfer the style of the photograph so it's black and white. It's got some new design on it. In 2015, to do style transfer, we needed a big desktop computer called a Titan X, processing at 0.004 frames per second. We've now squished it down so that we can do 30 frames per second on your smartphone. And therefore, you see AI used on your phones in things like MSQLD, where you can do funny pictures. but you also see different applications of AI that's more and more forthcoming. So, for instance, what can AI be used for? Wouldn't it be great if you go on a tour? Today you go on a tour, you have to either get a tour guide or you get one of those tape with a earpiece and you listen to what they do. But with AI on the phones, you could actually go visit a renowned site, but get information on that site in your local language. And as you face the front of that site, you get a different information. As you walk to different parts of the site, you get different information. So that's one use case of AI in the tourism industry. You could also use AI in a virtual reality or augmented reality world to add digital objects. So let's say you want to play chess with your grandfather who lives not in Seoul, but in a remote area. You could play the chess and add a digital object and play chess with him remotely in a different way. You could also use AI to modify existing objects. So in this case, this is actually a house that is modified to look like a Harry Potter castle. So if your children likes Harry Potter and they like Harry Potter castles, you could use AI to actually augment it so that they see that the house is actually transformed to a Harry Potter castle. But we are very, very early in AI. Even though we've made tremendous advances, we are very, very early. And this example will tell you why. Is this a vegetarian pizza? Anybody? No, you laugh. Why is it not vegetarian? It's got pepperoni. Pepperoni is meat. But meat, what is the definition of vegetarian? Why can't vegetarian take meat? Well, we know because we live in this world and we have the context of why a vegetarian does not take meat. So we look at a picture like this is easy. It's not vegetarian. But these type of questions confuses the computer because they still do not have the context to say vegetarians do not eat meat. And so we have a lot of work left to do in AI to get AI to the point that it's more useful for human beings. Because we need to teach the computer the context. So we're teaching the computer to how to recognize the pictures, computer vision. But without context, that vision is meaningless or is less useful. So that's very early in AI. Now, the second area that we're working on is VR and AR. So these are some of the cases that we are starting to see as we launch VR. On the top left is basically 3D sculpting. This is a 3D artist that is sculpting an animal using VR as a tool. On the bottom is 3D painting. So if you want to paint in 3D, that's possible. On the top center is, what if your kids want to visit the International Space Station? You have to stump up a lot of money. Well, you can't go there unless you're a trained astronaut. But AR or VR provides an ability for them to be transposed and experience the Space Center in a virtual reality world. But VR also has significant medical use cases. This is a case in Sao Paulo in Brazil where they are using VR to treat patients that have spinal cord injuries. So they've lost control of their legs. They cannot use their legs. But with VR, we can train the brain cells because there's the feeling that he's walking or she is walking to actually refire the brain cells and the neurons for them to start walking again. There's also a use case in the hospitals and specifically children hospitals. In children hospitals and in the emergency room, there is a lot of stress on the physicians, on the nurses and the doctors, especially if they see young kids that are very badly injured brought in, and they have very anxious parents that are adding pressure to that. So to help train the doctors and the nurses to be able to deal with the stress that comes with working in an emergency room, a kid's emergency room, we use VR so that they can see and simulate the situation so that when they actually go into the actual operating theater, they're mentally able to handle it. The last use case I show here is actually heart surgery in Stanford. If you want to do an open heart surgery, it's a three-dimensional problem. It's not a two-dimensional problem. So what the doctors here are seeing is that instead of using models to train, they use AR to train for a specific patient how the heart and the artery looks like. And so that they can practice before they actually do it on the actual patient. So you can see that these these virtual reality use cases, we have just started. And both on the AI and the VR side, as we go out, we open source our AI framework and we open source our VR framework so that innovators can come in and build on it and we can go faster. But we are not done with VR. Of course, we started with SD, we went to HD, we went to 4K HDR, and now we are in 360 video. But really what we want to get to is 3D 360, so that with a 360 view you have three-dimensional view, but also you get 6 degrees of freedom 3D 360. What is it? What do you mean by 6 degrees of freedom 3D 360? So today in a VR environment, that view is locked. So even though if you pan left and right and you look up and down, that view is more or less the same. What 6 degrees of freedom gives you is this. So here you see this lady, and that 6 degrees freedom camera is placed in one place to take a picture on the scene on the left, which is like a forested area. And she walks forward and she looks down. Because of that 6 degrees of freedom, we are able to reconstruct what that scene looks like when she looks down. So this becomes much more immersive and much more real to the end user that's using VR. However, VR is also very early. The bottom is what the human eye is capable of looking, and the top is what VR technology is at today. And so we still have a long way to go before VR becomes truly equivalent to the human eye. So now, besides AI and VR, we are also working on things like how do you directly tap into the brain interface. So today, as you work VR, you have a control like this one, and you're pressing a button. But you're actually, what is actually happening is your brain is asking your finger to press the button. And so what we're saying is that can we actually directly interface into the electrodes in the brains and have signals bypass a screen, bypass a device like this, and unlock human potential? We all understand that actually the human brain is much more capable than its interfaces. Interfaces are of sight, our hands, and so on and so forth. So an interesting use case for this is we're working with this doctor in Stanford. She has ALS, so basically Lou Gehrig's disease. She doesn't have use of her limbs. And here, what she's doing is typing with her brain. So as she imagines her hands moving to where the screen is, the computer figures out what she wants to type, and she's able to get about 8 words a minute. This is still much slower than what we can do on a smartphone. We do about 20 to 24 words per minute on a smartphone. So what we want to go with this system is to get it to about 100 words a minute so that it's better than what we can do on the phone. So the question is, how does AI, VR, and some of these tie back to connectivity? It's important because as social media as a platform evolves, we started with text. So when, in 2007, when I went to Italy to share my experience, I would type a text. And then we evolved to pictures. And then we evolved to say, hey, video is actually better. So now a lot of posts on social media, on Facebook, is video. But what we are really going is to allow people to post using an AR and VR concept, so that your friends are actually transposed to where you are and can experience what you're experiencing in a much more immersive real-time situation. And none of this will work if the connectivity is bad. And that's why we're interested in connectivity. And we have a really interesting case where we saw connectivity either being an enabler or being a bottleneck for us serving our end users. So we launched Facebook Live not so long ago. And what we noticed, and this is just one example, is that if the user is in Western Europe, it's got good connectivity, he will get a lot of views around Western Europe. He will get good views in North America. He will get good views in Korea, it's there. But where the connectivity is bad, the view is actually much, much, much lesser. And so connectivity is a basic prerequisite for us to be able to deliver not just Facebook Live, but some of the more immersive content that we plan, like AR and VR, in the future. So then we looked at what the world is like. This is how we see users accessing Facebook. So yellow means it's coming in on 4G, blue means it's coming in on 3G, and then red means it's coming in on 2G. And so Korea is great, it's all yellow, but a lot of other parts of the world are still coming in on 2G. And 2G technology is actually 25 years old. Yet it is the dominant technology for most parts of the world. So for the developing parts of the world, it's important that we convert the red to yellow. For the yellow parts of the world, it's important that we make the yellow even better by an order of magnitude of 5 to 10 times. So how are we doing that? We set up an open source foundation called Telecom Infrastructure Project. Telecom Infrastructure Project is set up with the aim of fundamentally changing the way that telecom networks are built. SK has been a really good partner for us. Dr. Choi, the CTO, is chairman of the board of directors of TIP. SK has contributed ideas that are in project groups today that is disaggregating the way that we build telecom networks. I don't understand Korean, but I heard a lot of open source terms in the previous discussions. So I know that there's a big shift towards open source. So what we're trying to do is to give it a big push in TIP to get open source adopted into the telecom world. Why do we believe in open source? We believe in open source because we build our infrastructure on open source. When we build our data centers in the very, very early days, we built it on traditional IT hardware. And we very quickly hit a point where we knew that if we continued on that path was not sustainable, both from a cost as well as from a flexibility innovation perspective. So in 2009, we undertook a massive shift to move towards open source data center designs, meaning the physical building of the data center, and also open source data center hardware, the compute, the storage, the networking, which then allow us to drive a much lower cost structure that now allows us to serve different types of content within our data center. But more importantly, going down the open source path provided us control of our own destiny. If we could innovate much quicker, we could launch products and features much, much quicker on our platforms than if we would have gone down the closed but integrated path. So open source literally save our bacon and continue to be a fundamental building block of why Facebook is successful today. So as we made this transition to open source within the data center, we're saying, can this same open source concept be translated into the telecom infrastructure project? So that is why we set it up. So telecom infrastructure project is really about how do we get open source projects adopted in the telecom world. But what we're trying to do, the second bit that we're trying to do that's very important in the telecom infrastructure project is community. Not just a community of open source players, but a community of like-minded telecom players that will signal to the open source players that they are serious and interested in open source use cases, they will use open source technology to drive the technology forward. And that's why you see these names here. There's a bunch of 450 plus names, big names in the telecom world that has realized that this shift is needed, and they are very much behind this. Now, so open source is great, but besides open source, Facebook's also contributing some of our technology, and we are open sourcing it. So we're not just saying, okay, we set up this tip, it's all fine and dandy, you guys carry on. We're saying, where needed, and there's significant R&D resources that are needed, we are willing to put R&D resources to work. So you heard of drones, Aquila, which is our drone platform. So nobody else is doing a controlled drone, and we're doing that. And the idea is, as we do drones and as we commercialize them, as we bring them closer to commercialization, we would open source that design too, so others can take it and innovate. Another example is millimeter wave. I know in Korea, there's a very fiber-rich environment, but increasingly fiber is difficult to put down onto the streets because people don't like you digging up roads and so on and so forth. So there's a new class of millimeter wave technology that we've done some research and development on to provide gigabit speeds on air interfaces, on wireless interfaces. But the challenge to deploying these in a big city or in a city like this is not the technology. The technology can be fixed. The challenge of deploying this is how do you know which pole to deploy it on? How do you send people out in the traditional way to deploy it? Could we use some of the AI intelligence that I talked about to solve this problem? So this is an example. So we did a trial in the city of San Jose. This is in California. We took high resolution image of 1 billion points across 1.74 square miles, about 26 miles of roads. And what we were able to do is that we were able to train, using AI, the computers to pick out buildings, to pick out trees and shrubs, which are the pink ones. And then we trained the computers to pick out utility poles, street lamps, power poles. So these are the ones that are in green. So we were able to process a city like this, 1 billion points, in about 8 hours, and we found slightly north of 1,000 poles and 4,000 plus line of sights. So suddenly, you don't need humans to go out and figure out where there is line of sight to deploy these millimeter wave systems. The computer does it for you. And of course, that being the first time, we actually did send humans out to say, are these line of sight for real or they're not for real? And what we were able to see was actually the computer was able to pick out line of sight that the human would otherwise not see. So we did a control test environment. We sent humans out to figure out the line of sight. We used AI to figure out line of sight. We compared the two. The AI algorithm actually works better than the human mind in this case. So we're using some of these technology to solve some of these challenges. The challenge in this case is not the technology. So we've done some of the technology. The challenge in this case is how do you easily deploy it in an efficient way. Now, besides technology and open source, we also looked at how do we get more startups excited about telecom hardware and software. So we worked together with SK now to launch the TIP ecosystem accelerator. So the aim is to create a global and sustainable ecosystem that attracts the best entrepreneurial minds back into telecom. But why is it a problem to start with? I still remember when I first started, there were a lot of telecom startups in the early 2000s, in the late 90s and 2000, before the dot-com crash came along in 2001. And after that, it's been a steady trickle decline. And the reason is what we call the $0 to dollar problem. I'm not saying SK is this, most telecom operators take at least 12 to 18 months before they make a buying decision. It involves very extensive RFP process, POC process, BMT process, and then finally when they're happy, they said, okay, we give you a PO, we buy. So because of that long process, the VC says, actually, maybe that's not the best use of my money. Because I don't know whether at the end of 24 months, that startup that I fund will actually get revenue. So this is the zero to the dollar problem. And because the VC money is not there, the startup says, forget it, I'm not going to go in there. And what the end result is a stagnation where there's little innovation coming from startup companies, and there's a big emphasis on backward compatibility versus how do we bring this forward. So what the TEAC is set up to try and address is to try to reverse this spiral and bring about disruption. So what we're asking is for like-minded leading telcos like SK to signal to the market that if a startup has interesting technology, proves it in the lab, it's a much shorter cycle to get into a commercial network and to get money. That's the first problem we're trying to solve. Second problem we're trying to solve is, now, if the leading telcos are willing to send this signal, are we able to get VC monies back on the table? And if that is, we believe that the startups will come. And then once the startup comes, disruption will happen again. And so we now have 3 of these centers worldwide. SK is the first and the only one in Asia. Then we have 2 in Europe with BT and Orange. And with the BT one, we were able to attract a bunch of venture capitalists that basically said, yes, if they're good ideas, we would fund this startup to the tune of $170 million. So it seems to be working. We can attract the VC funds, provided the leading telcos signal to the market that they're willing to compress the adoption. So you will notice that we did not pick these locations by chance. We picked these locations because we assessed that in these 3 places, there was a good, deep engineering talent. 2, there is a stable of venture capitalists that has money. And 3, there was a telco that was willing to say, I'm giving that signal that I will compress the time to market. So these 3 locations are not coincidental, they're deliberate, and we are looking for more locations, and in due course we will announce more, but we're very happy that SK is supporting us in Korea, in APAC. So this is the last one, which we announced in April, and this is the one in Orange. And the reason for Orange is, of course, also the fact that Orange has a lot of operations in Africa, which is the part that is all red, as I showed you just now, and that innovation can benefit. Now, each of these 3 centers do not work in isolation. It doesn't mean that the ideas that surface in the Korea one will only stay in Korea. The idea as we set up more and more of these TEACs is that an idea that is good in Korea, if it's applicable in Europe, in Africa, in other parts of Asia, will have an avenue to get out to these markets. So we're bringing the world, if you will, to the startup ecosystems here in Korea to say, this is your oyster. If you have a really good idea, go chase it. So we look forward to many, many good ideas and many, many good startups that come and make use of the TEAC here in Korea together with SK and bring the technology forward to the rest of the world. Thank you very much.
Thank you. 네, 오늘 좀 시간이 지연돼서 죄송하고요. 마지막 세션이 남았습니다. 그래서 방금 설명하신 그 페이스북에서 얘기하신 팁하고 TEAC 서울에 관련해서 저희가 진행하는 프로그램에 대해서 간단히 담당하시는 이지용 매니저님께서 설명해 주실 예정입니다. 여러분 큰 박수로 환영해 주시기 바랍니다. 네.